All right, so today we're going to do E2.1, which is relations and functions. We need to know the difference between those two things first, so let me give you a couple definitions. The first one is a relation. A relation is any graph, okay? Or in other words, any pairing, or I shouldn't say pairs, any pairing of inputs and outputs. Any pairing of inputs and outputs, okay? A function specifically is a special relation where each input, and our inputs are our x values, so each x value or each input has only one output, and our output values are our y values. Okay, a special relation where each input or x value has only one output, which is our y value. Okay, the other way that we know is that it passes the vertical line test. Okay, passes the vertical line test. So I want to show you a few different ways to represent relations and functions to help us decide if it's a function. So the first way is just to make a table. Okay, when we make a table of values, we usually pick our inputs, which is our x's. We just plug them in to see what our outputs are, or our f of x's. Okay, so here we have f of x equals x squared, and we want an input of -2, which means I'm putting -2 into my function to see what it equals. My function squares it, so -2 squared gives me 4. So that's my output. Same thing with -1. If I plug -1 into my function, -1 gets squared, which is +1. Okay. Same thing with these other ones. I don't really need to write them out, right? If I put 0 in, 0 squared is 0. If I put +1 in, +1 squared is 1. If I put 2 in, +2 squared is 2. Okay. And then the other way we can look at it is by graphing it. Okay, so now that I have this table, I can go ahead and just plot the ordered pairs that this table makes. So my first input was -2, my output was 4. So on my x-axis, I'm going to plot my input. On my y-axis, I'm going to label it f of x and plot my y. So at -2, I'm up at 4. 2, 3, 4. At -1, I'm up at +1. At 0, I'm at 0. At 1, I'm up at 1. And at 2, I'm back up at 4. So if I draw a line through my values here, notice what we end up with is a parabola. Okay. So here, since we have a picture, we can actually go ahead and do the vertical line test. Remember, the vertical line test says if I take any line, any vertical line, and draw it anywhere on this graph, it should only cross it one place. So notice here I drew 3 random vertical lines, not very straight, but notice they only hit the blue line once. So that means this would be a function. Okay, and I'll just put over here, let me use a color that shows up a little bit better. If I were to draw a vertical line, I'm just going to put down here, passes vertical line test. Okay, so let me go ahead and come down a little bit. Let's look at another way. Another way to express a relation or a function is using an equation. Okay, anytime we write it as an equation, our x that is here inside the parentheses, that is our input value, and most of the time it's x's. The f that's outside the input value, that's just the name of the function. Okay, so I'm just going to put down here, this is the function name. Okay, so whatever we plug in as our x, that's our input. Whatever we get out is our f of x or g of x or k of x or whatever name we give that function, and that represents our y value. So the next thing is to show this as like a machine. Okay, a function does something to your input in order to give you your output. So here we start with our domain, okay, again, which is our input values, and I'm just going to pick the ones we did in the table. So we plugged in -2, -1, we plugged in 0, we plugged in 1, we plugged in positive 2. Okay, when we plugged those in, those were our input, okay, which is our x's, and we plugged them into our f function, which we're thinking of as a machine, and what our f did is it squared it. So it took our x and it squared it, and what came out was our output, which we're calling f of x, because that's the name of this function. Okay, and the values that we got out were 0, 1, and 4. Okay, so anyways, after we've looked at this, we're looking, does every input have exactly one output? Does every x have one y value? Okay, negative 2 had one y value, it was 4. Negative 1 had one y value, it was 1. Okay, notice some of my y values got repeated, but that's fine. As long as each x goes to specifically one y, it doesn't matter how many times that y gets repeated, as long as there's only one y for each x. So here, our final analysis, is this a relation or a function? I'm going to go ahead and mark that yes, it is a function. And the way that we know, first of all, is that it passes the vertical line test. Okay, and the other thing is there's only one output for each input. Only one output for each input. Okay, so let's go ahead and move on down. Look at another one. Now this one's a little bit different. Notice it's y squared equals x. It's not solved for y, it's solved for y squared. So what I want to go ahead and do is I'm going to move this down, and I'm going to say, before I start working it, I always solve for y to make it easier to plug in x values. So I'm going to say solve for y to make it easier to plug in x values. Okay, so if I were to take this and solve for y, I have y squared is equal to x. To get rid of a square, we take the square root of both sides. Don't forget your plus or minus. So I take the square root of y squared, I get plus or minus the square root of x, which means that y is equal to plus or minus the square root of x. Okay, so instead of using this function as it was written up here, I'm going to go ahead and use y is equal to plus or minus the square root of x. That way it's already solved for x, it's easy to plug things in. So the first thing they want me to plug in is 0. So if I do y is equal to plus or minus the square root of 0, I get 0, right? Because positive square root of 0 is 0, negative square root of 0 is 0. So my only output is 0. Now, if I plug in 1 for x, I get y equals plus or minus the square root of 1. Now, 1 is a perfect square. If I take the square root of 1, it gives me 1, but that plus or minus is going to give me two different answers. I'm going to get positive 1, and I'm going to get negative 1. So when I plug in 1, I'm going to go ahead and put here, I get two outcomes. I get 1 and I get negative 1. Same thing happens when I plug in 4. If I plug in 4 and I do plus or minus the square root of 4, I'm going to get y is equal to plus or minus 2, right? So on 4, same thing happens. I get a positive 2 and I get a negative 2. So let's go ahead and see what this looks like if we graph it. When I plug in 0, I get 0. When I plug in 1, I get 1. And I also get negative 1. And when I plug in 4, I get positive 2. And I get negative 2. So notice this one looks like our picture from before. The only difference is our parabola is turned on its side. Now, when our parabola is turned on its side, notice if I were to do the vertical line test, it's going to hit two places. If it hits two places, then it fails the vertical line test. Okay. Fails the vertical line test. So already we know this should not be a function, because to be a function it has to pass the vertical line test. So we know it fails. Let's go ahead and look at it as an equation and as a machine. Okay, as an equation, again, when we solve it, I'm not going to resolve it because I did it above. What I end up with is y is equal to plus or minus the square root of x. Okay, which means that y is equal to the square root of x, and it also means that y is equal to negative square root of x. So notice I can't write just my one outcome as one function. Okay, so I'm going to go ahead and say this can't be written as a single function. Okay, the only way we could write it with a single function is to use plus or minus, but again, plus or minus gives us two answers. So the fact that we can't write it as a single function is making us think it's probably not a function. Okay, so again, our domain, I'm going to pick the values that we plugged in from our table, which was 0, 1, and 4. Those are our x's. We plugged it into our machine, which here it says R. I don't know why it says R. We actually are using Y. Okay. When we plug it into our machine, well, I guess I don't have to erase that. It doesn't matter. We didn't write it as a function, but when we plugged it into our machine or into our function, what happens is we did plus or minus the square root of our input, and the outputs that we got were 0, 1, and 2, but we also got -1 and -2. Okay, so notice one output here, actually more than one output has, or sorry, more than one input has more than one output, if that makes sense. Okay, so let's just write it as one input value. So specifically like 4. Okay, 4 was an input value, and this one input value had 2 outputs. Okay, and we can't have 2 outputs. So when we go down here for our final analysis, we're going to have to conclude that this one is a relation, and it's a relation for several reasons. One, we know that it fails the vertical line test. Fails the vertical line test. We also know that it cannot be written as a single function. Whoa, that doesn't look very pretty. Let me try again. Cannot be written as a single function. Okay, and then our last thing is one input has 2 outputs. And I'll just say, since there's more than one, I'll say there are input values with 2 outputs. Okay, and that's a no-no. Every number that we use as an input can only have one output. So here, this is a relation. Okay, the other thing that we're going to look at dealing with is we're going to specifically look at some functions. And the thing that we need to know what to do with functions is how to evaluate them. Okay, so let's go ahead and move down here. Whenever we're evaluating functions, we're plugging in a value for x, basically. Okay, so I'm going to go ahead and just say anytime you see evaluating, you should be thinking plugging in. Okay, we're plugging in a value for x. Now, not always are we going to plug in something for x. Sometimes we just take a function and we add something to it. Okay, we add to the output or we subtract from the output. But basically, we're looking what's inside our parentheses. If it's anything other than an x, that's what we're going to plug in for x. Okay, so on this first one, they give us f of x equals 3x plus 4. So notice, whatever is inside the parentheses, that's what's going to go in for x. So here we have f of 2. Since 2 is inside our parentheses, 2 is going to go in for x. So I do 3 times 2 plus 4. Okay, again, whatever's inside our parentheses goes in for x, and then we just simplify. So 3 times 2 is 6, plus 4 gives me 10. So f of 2 is 10. Or the f function evaluated at the input value of 2 gives me an output value of 10. Okay. Now this next one's a little different. Notice we're not changing the inside of x. The inside of f of x is still just f of x. So what this means is this is our original function. And notice all we're doing is we're multiplying our original function by 2. So I'm just going to write that out. So I have 2 times my original function, which was just 3x plus 4, and then I'm multiplying it by 2. So I need to distribute. 2 times 3x gives me 6x. 2 times 4 gives me 8. Okay. Same thing on the next one. I look inside my parentheses, inside my function for my input. Here it's still x. If the only thing in there is x, then this is still just my original function. So I'm just doing my original function, and then I'm going to add 2 to it. So my original function again was 3x plus 4, and then I'm just going to add 2 to it. So when I simplify, I can combine like terms, 4 and 2, which gives me 3x plus 6. Okay, makes sense a little? Let's look at some more. Okay, on this first one, I have the same function, 3x plus 4. I look inside my parentheses. Now, inside my parentheses is what I'm plugging in for x. Here I don't have an x, so I'm plugging in whatever's in those parentheses, which happens to be an a. I'm plugging it in everywhere I see an x. So that means f of a is equal to 3 times a plus 4. Notice, a is inside the parentheses, a is what goes in for x. So here this is the same thing as saying x equals a. That's what I'm plugging in. And then there's really nothing to simplify here. Instead of writing parentheses, I could just do 3a plus 4. But there's nothing to combine, so I'm just going to leave it like that. Let's look at another one. This one says f of a plus h. Now this little piece is the piece that we just did in the last problem. So I'm just going to say, from previous problem, we know that this equals 3a plus 4. And now all we have to do is add h to it, right? So I can draw my parentheses because I'm just adding, which means that f of a plus h is the same as 3a plus 4 plus h. Okay, so that one was kind of nice because we already did one little piece of it. If we've already done one little piece of it, plug in what you know it to equal and then just do the other part. Okay, now here's the one that everybody hates. Anytime I'm looking for f of x and I'm given a function, remember, whatever's inside the parentheses is our x. That's what we plug in. So here notice we have a quantity inside the parentheses. That means that that quantity is what I'm going to plug in for x. Or in other words, x is equal to a plus h. So I'm going to do f of a plus h is the same thing as doing 3 times, normally where I would have my x, I'm going to put a plus h plus 4. So I'm writing my original function. The only difference is I'm putting in a plus h for x because a plus h is what's inside my parentheses as my input. And then I just simplify. When I distribute my 3, that gives me 3a plus 3h plus 4. I'll leave it like that. Okay, let's look at another one. Now, these ones are using the same function, so I'm going to go ahead and write the original function up here just so that I have it. We're using f of x is equal to 3x plus 4. Okay, so I don't have to scroll up and down. So notice this one has 2 pieces. It has f of x plus h, and it has f of x. Okay, so I'm going to do both pieces, and then I'll worry about subtracting them. To find just f of x plus h, again, this is a quantity that's inside my parentheses, which means that's the quantity I'm going to plug in everywhere I see an x. So in other words, x is equal to x plus h. And I hate saying it like that because I'm using an x here too. Excuse me. So we're just going to say whatever's inside the parentheses, that's what plugs in for x in my original. So my original function says to do 3 times my input and add 4. And here my input is x plus h. Okay? And then I'm going to go ahead and distribute it just to simplify it. So I have 3x plus 3h plus 4. So this is my f of x plus h. Now I want to look at the second part. The second part that I need to know is f of x. Now f of x, this is just my original function, right? I'm not doing anything to it. There's still an x inside the parenthesis. So I know this is just 3x plus 4. So here's what I'm thinking. This little piece, f of x plus h, we simplified to get this. Okay? And then we have over here minus f of x, which we know to be our original function, which is 3x plus 4. So now all we have to do is put those two pieces together. So that means that, excuse me, if I do f of x plus h minus f of x, what I'm really doing is 3x plus 3h plus 4 minus 3x plus 4. And then I just simplify. Okay, I need to distribute that negative. So I get 3x plus 3h plus 4 minus 3x minus 4. Now notice when I go to combine like terms, my 3x's are opposite signs, so they cancel. And my 4's are opposite signs. So all I end up with is 3h. Okay. So now I want to look at the second part. The second part says to do f of x plus h minus f of x all over h. And what I want you to realize is if I write out this horrible, ugly looking fraction, which you will learn as the difference quotient, the whole numerator is the part we did in part G. This is our solution from part G. So I'm just going to go ahead and plug it in. We know that it was 3h, and now I'm just dividing it by h. When I do 3h divided by h, I can reduce my h's, which leaves me with just 3. Okay. So the best way to tackle these big ugly things are do one piece at a time, and then put it all together once you have all the little solutions. Okay. Okay, let's look at this one. Now, if you write big, you're going to want to write small on this one because it requires a lot of working out space. So I'm giving this rational function, and I want to determine f of x minus 1, f of x plus a minus f of x, and f of x squared. Okay, so I'm going to go ahead and do the two easy ones first because I've already worked this out. So I'm going to go ahead and do f of x minus 1. F of x minus 1 says wherever I see an x, I'm going to plug that in. Whatever's inside my parentheses is what I plug in for x. So here I have a quantity. So notice my function says whatever's inside the parentheses goes in, and I add 3 to it, and I subtract 2 from it on the bottom. So that means I do x minus 1 plus 3, x minus 1 minus 2. Okay, notice whatever's in my parentheses, that's what I put in where my x's were. Okay, and now I can just drop my parentheses and simplify. Okay, when I simplify here, I get x minus 1 plus 3 and x minus 1 minus 2, which gives me x plus 2 over x minus 3. And I just leave it like that. Okay. The next one I want to do is I want to do this last one because it takes up very little space. If I want to find f of x squared, that means I'm going to plug in x squared for my x's on top and bottom in my original function. So I'm going to do x squared plus 3 all over x squared minus 2. Okay, so notice wherever there was an x in my original function, I'm now putting in x squared. Now here I don't have anything that I can factor. There's not a difference of squares. Nothing's going to cancel. So I just leave it as it is and drop my parentheses. Okay. So the last one that I have to do is this middle guy, which has two parts. So I have f of x plus a minus f of x. Excuse me. And I'm going to go ahead and do it all together. Okay. So this first piece says that I'm going to plug in x plus a in my original function where I see x's. So my original function says to do input plus 3 all over input minus 2. So my input is I'm putting in x plus a. Okay, so I'm done with that piece. I just put that in. Now I want to do the second piece, which is just, notice this is just my original function. So I'm subtracting my original function, which just looks like x plus 3 over x minus 2. Now, I want to go ahead and simplify this. I don't really need the parentheses on the first term because nothing's happening outside that x plus a. So I'm going to go ahead and drop that, which gives me x plus a plus 3 all over x plus a minus 2 minus x plus 3 over x minus 2. Now, I can't just leave it like this because there's two terms. Anytime we have fractions, we like everything together in one term. So I need to get a least common denominator. And here my least common denominator, I would need both denominators, which is x minus 2 and x plus a minus 2. So I want both of these to have that denominator so that I can write it all over that same denominator. Now if I want to write this all over, ooh, that's not straight. Let's try again. If I want to write this all over x plus a minus 2 times x minus 2. In order for this first term to have the denominator that I need, notice the denominator it's missing is x minus 2. So I would have to multiply on top and bottom by x minus 2. Now once I do that, the denominator looks the way I want it to, and on top what I have is x plus a plus 3 times x minus 2. Now I want to do the same thing on the second one. The second term is missing the denominator x plus a minus 2. So I would multiply on top and bottom by x plus a minus 2, just like we do with regular fractions. So I end up with minus, and actually, you know, the easiest way to not have to worry about this negative is to go ahead and distribute it up here and change the signs. Have you ever heard of plus a negative? I'm going to go ahead and change it by moving that negative up to the top, and then we don't have to worry about it. So I'm going to change this to plus a negative, and when I change the sign, I have to change it on both of them. Okay, so I'm going to go ahead and put down here that I'm adding, and when I changed that to a plus, I had to distribute that negative to both terms here. So I have negative x minus 3 times the denominator that term was missing, which was x plus a minus 2. Okay, so I did two things there. Actually, I did three things here. I found a common denominator. I multiplied on top and bottom of each term what they were missing so that they have that denominator. In the process, on the second term, instead of having to remember to distribute a negative later, I just went ahead and changed that to a plus sign and moved the negative to the numerator and distributed it to each term. Okay, so now all I need to do is FOIL out the top and simplify. So I'm going to go ahead and start distributing. On this first one, when I distribute my x to two terms, I have x squared minus 2x. I'm going to distribute my a. A times x is ax. A times negative 2 is negative 2a. And then I distribute my 3. 3 times x is 3x. And 3 times negative 2 is negative 6. Okay, so that was my first quantity. Oh, I guess I don't need parentheses. And then when I'm adding to that, this second part that I need to distribute out. Negative x times x is negative x squared. Negative x times a is negative ax. Negative x times negative 2 is positive 2x. And then I'm going to distribute my 3. Negative 3 times negative a, and I'm going to move down here. I know it's bad form, but I ran out of room. So negative 3 times x is negative 3x. Negative 3 times negative a is negative 3a. And negative 3 times negative 2 is positive 6. All over my least common denominator, which was a plus x minus 2 and x minus 2. Oh, I redid the order. Well, it doesn't matter. And now I need to combine like terms. So notice on the top I have a positive x squared and a negative x squared. I have a positive and negative 2x. I have a positive and negative ax. I have a positive and negative 3x. And I have a positive and negative 6. So the only thing I'm left with here when I'm looking is I have this negative 2a and negative 3a, which leaves me with negative 5a all over my common denominator, which was x plus a minus 2 times x minus 2. And we just leave it like that. Okay, I know that one looked really nasty. There was two pieces. I had to find f of x plus a and I had to have my original function. Then I subtract those. Now in order to subtract them, we had to get a common denominator. Once we have the common denominator, we multiply the two numerators by what their previous denominator was missing, and then a lot of foiling and combining like terms. Okay, so on the next page and a half, there's 3 for y'all to try. I'll give y'all some time and then we'll go over them. Okay? We're finding g of x plus 2, and then g of x plus h, and then g of x plus h minus g of x. So in blue, notice our original function isn't changing. We're just adding 2 to whatever our original function was. So we combine the 5 and the 2, which gives us negative 2x plus 7. On the second one, which I did in this turquoise color, here we're doing our g of x plus h. It is on the inside of the parentheses, so that quantity gets plugged in for x in our original function. So we're doing negative 2 times our new input, which is the quantity, plus 5. And then all we have to do is distribute the negative 2. On the one I did in purple, we're doing 2 quantities and subtracting them. And notice the 2 quantities are ones we already know. The first part, g of x plus h, is what we just found in turquoise, and g of x is just our original. So I put them both in parentheses just to make sure. Since we have a negative, we have to distribute that. Once we distribute the negative, we're just combining like terms, and we should end up with negative 2h. Okay. On number 2, we have the same thing. So in blue, I take my original, add 2 to it. Now here, because my original was a fraction, I have to get a common denominator. So I wrote 2 as 2 over 1, and then I had to multiply on top and bottom by x minus 3. That gave me 2x plus 3 plus, when I distribute the 2, 2x minus 6, and then I just combine my terms on the top and put it over my least common denominator, which was x minus 3. The second one in that turquoise color, here we're plugging in for our input, so we're putting that quantity x plus h everywhere we see an x, in the numerator and the denominator, and then we just distribute. So I get 2x plus 2h plus 3 all over x plus h minus 3. It's already one fraction, so there's no common denominators. We're done. For the purple part, just like before, the g of x plus h we did in the previous step in the turquoise, and then we're subtracting our original function. Now again, since we're going to have to get nasty common denominators here, in pink I went ahead and changed that subtraction on that term to a positive. Now if I do a plus there, I have to move that negative to the numerator of my next term. So that makes it a negative 2x and a negative 3. Okay. Then I determine what my least common denominator had to have been, which here is x minus 3 and x plus h minus 3. And I multiply on top and bottom by what each fraction is missing. Now here I didn't write that I did it on the bottom, so I can go ahead and write that in. This first one, I would have to multiply by x minus 3 on top and bottom. On the second one, I would have to multiply by x plus h minus 3 on top and bottom. So now both of those terms have the denominator that we want. So I just put it over one denominator and then wrote out the string of terms on top. So on top we have our original numerator times the denominator piece it was missing, plus our second term's numerator times the denominator piece it was missing. And then we just FOIL everything out. When we FOIL out that long mess, everything cancels except for a negative 6h and a negative 3h, which gives us negative 9h over our least common denominator, which was x minus 3 and x plus h minus 3. Okay. And then on the third one, we're finding the difference quotient, which is f of x plus h minus f of x all over h. If you go on to calculus, you become very familiar with the difference quotient. But for this class, if I ask you to find it, I'll give it to you on the test. I'll give you the formula. You don't have to memorize it. Notice we have two pieces we need to know, f of x plus h and f of x. F of x is just our original function. So I wrote that here in green, or that turquoise color, 3x plus 1. And then f of x plus h, since we're finding f of a quantity, that quantity gets plugged in for x. So when I plug in that quantity for x, I get 3 times that quantity plus 1. Then I just distribute my 3 in. I'm coloring that part as the purple, and then I'm just plugging it into my difference quotient. So you can see here my f of x plus h, I plugged in my 3x plus 3h plus 1 that I got for my answer, minus my original function, which was 3x plus 1. Notice I kept it in parentheses. If you're subtracting more than one term, you have to use parentheses, so you remember to distribute that subtraction to each term. Notice everything cancels except for 3h in my numerator, so I end up with 3h over h, which is just 3. Okay, so that is the end of E1.2. So you can now complete the E1.2 homework in MyMathLab along with the E1.2 worksheet. E2.1. I'm getting my E's mixed up. So you can now complete the E2.1 homework in MyMathLab along with the E2.1 worksheet that's posted under your course materials in MyMathLab. If you have any problems, let me know. Okay?